So now we're going to look at some convergence and divergence series tests. Then we're going to start off with the nth term p-series and geometric series tests. Sometimes the nth term test we call the divergence test. And the basic idea is that when you're adding up an infinite series, the numbers have to approach zero. Like they have to be getting smaller and approaching zero in order for the sum to have a chance. Because if I'm adding up like a whole bunch of ones, like if the limit of this series approaches like 1, for example, I would be adding up an infinite number of ones, and there's no way that that could be a finite sum and converge. So what we're going to look at is as n goes to infinity, just what does the term itself do. And this is the simplest sort of the test, and all it can tell you is if it diverges. It cannot tell you if it converges. So when we do this limit, we do 3n squared. I'm going to distribute this. This is going to be n squared plus 2n. Remember, the way we handle this is we simply look at what happens as n gets really big. The n squared terms on the top and bottom are the dominant terms. Like the 2n is not going to be as big as the n squared terms. That will cancel, and I'll just get 3. Now, because 3 is greater than 0, like basically in order for it to have a chance of converging, it has to be 0. Because this is greater than 0, this diverges. Actually, it's not because it's greater than 0, it's just not equal to 0. It diverges. Same with this one, we're going to take the limit as n goes to infinity of 2 to the n over n cubed. Now this one, if I plug in infinity, I'd have 2 to the infinity over infinity. It'd be infinity over infinity, which is a indeterminate form. And we're going to use L'Hopital's rule. We're going to take the derivative at the top and the bottom. It's going to be 2 to the n ln of 2, which is the derivative of the top. Derivative of the bottom is 3n squared. Okay? Still infinity over infinity. It's going to be 2 to the n ln of 2 squared, because it just multiplied by a natural log of 2 again. And this is going to be 6n. Still infinity over infinity. But finally, it'll be 2 to the n ln of 2 cubed over 6. This will be infinity over 6, and that's infinity. And so because that's not equal to 0, it diverges. Okay. So you're just simply computing the limit of each term as it goes to infinity. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.